Hey guys, I'm Volen and welcome to part 3 on how to make a video player inside of Godot. In today's episode, we'll be implementing FFmpeg inside of our GD extension and we will show how to open a video file. And opening a video file with FFmpeg is not necessarily how you would open a video file inside of a video player or any other program. So yeah, let's get into that. Boom. Like this and... So first of all, we need to include FFmpeg in our project. So same thing that we did with the Godot CPP stuff. We copy this URL, we go in here, git submodule, we add the link, and then the location of where we want it to be saved to. We want it to be part of the Gozen application, the gozen.gdextension. So we go gdextensions, gozen, and then a folder called FFmpeg. Normally this should take a little bit of time, it's kind of a big repo. And of course there's also the same thing that you have to do with FFmpeg that we also had to do with Godot CPP, and that's change the branch. So the moment that this is all loaded in, which is right now because of the magic of video editing. So we see it has a master branch, we need to change this to 6.0 or 6.1. I'll be choosing 6.1 because my system uses 6.1 and I don't think the changes are too big, and like you can see they're already working on 7.0. If you work with FFmpeg related stuff, you will notice that a lot of the examples out there are all based on 4.0, on the 4-point releases, and even older ones can go to version 3, which is very annoying if you want to find the documentation on how to do certain things. And talking about documentation, this is the FFmpeg documentation page. FFmpeg is mainly used as a command line tool. You can use it in C++ programs, but this is basically how most people use it, through a command line. We don't need that, we need the API documentation. Over here you can see some of the documentation for each one. One that we will use a lot are libav format and libav codec. I personally don't really use this type of documentation. I go to API documentation and I select 6.0. Basically this is what I use. They have some example files here as well, which are kind of helpful. So libav format and libav codec, these are the ones that we will mainly use, especially today, for opening files. I just noticed that I put the FFmpeg folder in the wrong position, so yeah. Git move, and we move them to GD extensions. If you have anything related to Git submodules and you want to move them around, use the command line. Don't just go dragging around the files because that will break things. Just use git mv for move, and normally this should fix things. So we have this folder, let's quickly delete this. Okay, so right now FFmpeg is included in the correct folder. Okay, and here is Volen from the future. I had some trouble with the audio of this part, so I will redo this part and you'll see the code. I adjust things a little bit, so some changes have been made. But first of all, the build script. Don't notice other files that you may not have yet. So the build scripts, we use subprocess now. It's easier. So subprocess run, then we have our commands, shell true, and then cwd is basically where should this command run from, and we want it to run from the GD extensions gozen folder. I also got here this one here for Windows. This is basically just for showing that the building for the Windows version, for the Windows platform, also works. And then next up, if you look into the source folder, let's hide this for now. If you look into the source folder, the bin folder is gone. So let's look at the file, what the changes are. Basically, I've added this part. So the bin is gone and I replaced it by this. So these double dots basically go out of the source folder into the main folder. Then the GD extensions folder, so this one. Gozen. And then libgozen, which will appear in here after we build it. So that's the second change. Let's first go over this. Let's first go over the SConstruct script. First of all, we need a couple more imports. This one is actually not needed anymore. So import subprocess. and then import platform as OS platform. I'll explain why we import platform as OS platform soon. Also, the destination folder is gone right now because we will put all the builds for the GD extensions inside of the main folder itself. So that's something that also changed. And then we have this environment.append libs libraries. So for FFmpeg, everything it has the AV. If you look in the documentation as well, you can also see lib AV util, AV codec, AV format, AV device, AV filter, SW scale, SW resample. So these are all the codecs that we need access to. So we add them and append them to the libraries for the environment. And basically, if you were only to use, only to compile for Linux, this is all you need. So this is basically compiling for Linux to make FFmpeg work. Also in libpath, I removed double brackets here. And over here, there was a destination there. So this was also here. I also removed this part. And then if platform is Windows. If you want to have it for macOS, you will choose platform Darwin. This would be used for macOS, but I don't have Mac. I don't want to figure it out. But you can see this is all of the stuff we need to make it work for Windows. So first of all, we need the FFmpeg bin folder. For this, we use a function called os.path join, and this will basically make certain that the slashes are the same, because on Linux we use this and forward or backwards, and we use the opposite for Windows. So this will basically handle that. So we take the os path dir name, so basically the directory name, the folder name, of the full path of the file, of the SConstruct file itself. So this part basically would give, let's copy path. This will basically give this. So storage, programming, gozen light, GD extension. So the full path from your folder. On Windows, this will be something like C or D. I don't know what drive letter you choose, but it will start with the drive letter, and it will point to the FFmpeg bin folder inside of the gozen folder. This is basically what this does, and then we make certain that the directory actually exists by making the directory. If it exists already, we don't create it and we skip this. And then we start with building FFmpeg. If you want to build FFmpeg for Windows on Linux, we need to have some extra arguments. So we have this entire function here. I said before that I would explain this. So import platform as OS platform. That is because platform is already an argument in here. OS platform is basically the class that has access to your operating system itself. So OS system, and then to lower, so we have lower capital, because I'm not 100% certain if there are capitals in the names or not. I just do this to be certain. So OS platform, osplatform.system, lower Linux. If it's Linux, we add opt-bin to our OS environment path. But if you want to compile for Windows on Linux, you will need these extra arguments. So you will need cross-platform cross prefix x86 ming w32. So yeah, you also need to make the arc to 64-bit and the target ming w. For people using Linux, if you want to compile for Windows on Linux, you need these libraries. So you need the ming w libraries, else this does not work. Else you cannot compile for Windows on Linux. This is basically the part that we need to make it work, to make compiling work on a Linux machine. And then we change the directory to FFmpeg. We need to have access to the files inside of this folder. And then we run a os.system. This basically runs a command like the same way that you would open a terminal, and run anything like, yeah. So we add a dot and then a slash configure because we need access to the configure file inside of FFmpeg. So if you open FFmpeg folder, you will see a configure file. This has a couple lines, just a few lines. Yeah, not that much. You can probably browse through this in like a day or something. But we basically add the dots and the slash to make certain that we use the file, because if you were not to do this, basically it will be trying to run a command called configure because it does not know if it needs a command or a file. So yeah, that's all we need. This should work. Then for the prefix, we add the folder. Where do we want the things to compile to? Where do we want all the files to appear? Then we want to enable GPL because the FFmpeg library, if you want to have access to 8.264, 265, we need the GPL libraries. It has to do with licensing. Licensing is very complicated. If you want to keep it LGPL because you want to use it more restriction free in your project, then you should just remove this line altogether. But take in mind, you won't be able to use certain video codecs. Then we enable shared because we want it to be a dynamic library. And then we add the config extra. If there are no, like if you run this from a Windows PC, you won't have this part. So what will be added is basically nothing. Then we make FFmpeg and then we install it. And with install, it basically creates the FFmpeg bin folder. Not the folder itself, but it will create all the files inside that we will need for compiling and running the GD extension. Then we have OS platform system.lower, again, just making certain that it will accept Windows as an argument and not struggle with like capital letters and such. And we append some libraries. And then we add a CPP path to the library, to the environment, and also a lib path. These folders will be inside of the main folder, and this will also be the main folder where the DD extensions themselves are. And this is important to know because when you compile the extension, when you compile the export, the Godot project, you will get the GD extension files with it, except for the FFmpeg bin. So you have to manually copy that folder, FFmpeg bin, to your export files, to your compiled Godot project. So that's something to take in mind if you use Windows or compile for Windows. And for the rest, everything stays the same. But because we have this folder which has around 200 files, 226 files, we need to copy this and we add this to our gitignore. This is important because you should never have binary files in your Git repository. And just to show that this works, so we open a new terminal and we will run the build script. So we run, Python build.py. This should take just a couple of seconds and that is done. You will see our thing got, our shared object got put in here. If you look in the gitignore, this is why the shared object is not included. Never include binaries. Never. Yeah. Always let the people compile it themselves or export the complete projects as a whole. And just to show that the Windows compiling also works, we go into the build.py. We take this, put this here. We run again, and normally this will take a long time. Compiling for Windows just takes a lot longer, and especially we still need to create the FFmpeg bin files, and that's what's happening right now. If you want, you can create a print over here and say like, okay, we're making the files, we're installing the files, just to have some more feedback. I'm keeping it simple for this project, so building for architecture x86-64 on platform Windows, and that's about all that we will get from information. And now we just wait. This can take some time. This can take some, yeah, kind of a long time. Especially because we need to compile the FFmpeg stuff. Okay, and this is also called ton building. So if you look in here, we can see our SO file and our DLL file and our FFmpeg bin folder. So if you export your project, these files will be included in your project depending on for what platform you build. But you will have to copy this one manually to your folder and give it to the people that will use your application. So yeah, back to Violin of the past. And I think we'll be going over the video file and video class itself in the next part. So yeah, have fun. Let's go into our source and open our video.hpp. But before we do that, let's create a new file called video.cpp. Let's include video.hpp. Normally this should not give any errors. Okay, it works. Okay, so double quotes. In Python, I often use single quotes, and in other programming languages, I often use double quotes. So we have our video.hpp, and inside of here, we have our class print something. Let's remove this. Let's also remove this for now, or let's just change this. So a path open video. Let's change this as well, and let's create a function called open videos. So it's a void open video, and we need a string which we'll call a path. And let's also have an extra argument here. So a bool is open. This should be false by default. So this will be helpful for later on if you want to get the audio from a file to really check if the file is open or not. If the file is not open and we try to use FFmpeg stuff, the entire application crashes. Okay, so let's copy this function. Let's go in here. And because this is part of the video class, we go in here, video, and 2 columns, and voila. So in here, we will start opening the video. But before we can open the video, we actually need to add some FFmpeg stuff, because we've included the FFmpeg stuff inside of our SConstruct, but we did not include it inside of our script itself. So first of all, FFmpeg is written in C. So remember what we did in video 2, I think? Oh, whoops. In video 2 on register types, we had an extern C. So that's the exact same thing that we need again, because this will be for C++ codes. So C, capital 1, C is important. Normally this should not give any errors, yes. And now let's include the libraries. So include, because they're libraries that we already have on our system, or that will be included afterwards. We need to have lib av codec.ace. And this is probably something where Windows users will run into trouble. They will probably first have to compile FFmpeg and do the same Ctrl+Shift+P, edit configurations. They will probably also have to add those paths inside of here, so the include path and such. Because else I don't think autocorrect will work and it will keep throwing errors. And we also need format. We also need device. From AV-util we will need AV-dict for dictionary. Not AV-dict, it's just dict. Then we will also need channel layout. We'll also need opt, optional, and image utils. I'm not certain about this one, but I think it's best to add this one as well. Pix description. And of course the SW scale. Only this should not give any problems, yes. And then resample. So these are a lot of includes. Luckily we can just minimize them, so you don't need to look at them. So how do we open a video file with FFmpeg? It's getting complicated from here. So please watch this video multiple times if you don't understand it. And if you have any questions, please leave them down in the comments. And let's start. So first up, we need to allocate a video file context. But how do we do that, and what is the context? Well, yeah, you'll hear a lot of things that you probably never heard of before. So we go to video HPP and let's create a AV format context. And let's call it AV format context, just to keep everything kind of simple. Basically, the format context is, it gives you an entire description and all the things that you need, all the information that you need about a video file. So this is important. Without this, you cannot open your video file. Then we go to CPP and let's allocate some memory for this. Because we're still working with like C and C++, memory management gets kind of complicated. So AV format, we need to allocate context. This is giving an error, and I think I know why, because this should be a pointer. If you want to learn about pointers, I'm not your guy. Normally this will go away. And now we need to check if there's actually, if it actually succeeded. If this is false, then basically something went wrong and we did not open the context correctly. Let's do utility functions and let's have a print error. And this basically const allocate AV format context. And then we go, and then we return. And I'll implement one more function just because I think it might be helpful for cleaning up. So we have open video. Let's also close video, because like I said before, we need to do memory management. If the application closes, and let's better also create the initializers for that. And this one, the moment that you see this squiggly line, that's what needs to happen when a class goes uninitialized. And for that, we need to close the video so we are certain that all the memory gets cleared up out of the application. And for this, first of all, we need to set is open to false again, so we know the video file is no longer valid. So if you're doing multi-threading and it's trying to access this video class, first you need to close it before we remove all the things, because else, again, errors can occur when it's trying to access empty FFmpeg structs. If there is an AV format context, then we need to AV format close inputs. Yeah, and we have to specify that it's a pointer. So, whoops, normally this should work. Okay, so if this one has been assigned at some point, this will basically close it and get rid of the memory. Okay, so now we got our context ready. Now we have to enter our file. Format open inputs. In the close one, in the close function, we have close inputs. Here we open inputs. And then we just look at the arguments that it requires. So we need a pointer, an AV format context pointer. We already created that one, so AV format context. Next, we need a URL, or basically a file location. FFmpeg can also be used with online streams, so that's why it's probably called URL. But for us, we need to use argument path, a path. But this is requiring a const character pointer, because strings are not really, they don't really exist natively in C++. You need to use our std, but we have the Godot string. So basically we need to convert this to UTF-8. What the UTF-8 function does is basically it returns a character string. Oh, and I just noticed AV format context is giving an error because it has to include, like, do the whole pointer thing. And then we have two more arguments that we need to fill in. So we have a input format and an AV dictionary. We don't have those, so let's just put null in here. If this was not possible, and again, close video and return. Okay, so if everything went well, normally we have opened a video. So let's quickly build, Python. Okay, so close video is not declared. Am I doing something wrong? Oh, wait, no, close video, yeah. We need these over here as well. And normally this will build. Okay, so if you go into Godot, we will need a file. So if you run this now, this won't work anymore. So let's remove this. Let's remove the path as well. And video.open video. We need a path right now. So let's quickly create a const here. Const video path. It's a string. And I'll be taking my outer file. So let's copy the location. Let's go back to Godot, paste, and over here, video path. And normally this should not give any errors. And if you look inside of here, in the Godot editor, we also see there are no errors except for too few arguments for open. That's from before. So everything works for now. So next up, we have allocated the context. We opened the file, but a video file is actually made out of different elements, and one of those elements are called streams. So we have a stream for videos, we have a stream for audio, we have a stream for subtitles. In this version, I'll mainly go over getting the first available audio stream and the first available video stream, but it is possible that there are multiple video streams, that there are multiple audio streams, that there are multiple subtitle streams. I won't handle subtitles in here, but that is something you could also get. It's not that difficult, so if there's a need for it, if people want to see me implement the subtitles as well, add the subtitle system to this video player, please let me know in the comments. But yeah, find stream information. And it's actually quite simple to define that. So AV find stream, AV format find stream info. Then we take the AV format context that we created before, and normally it requires one more argument, which is options. We don't have any options right now, so that can just be a null. If this was not possible, something went wrong again. So again, utility functions print error. So again, close video. Let's not forget the things right now, and let's return. But yeah, the main reason why we do that is basically to load in the stream information in the context itself. So read packets of media file to get stream information. This is useful for file formats with no headers such as FFmpeg. This function also computes the real frame rate in case of FFmpeg 2 repeat frame modes. So not all video codecs are built the same, and when working with different video formats or working with FFmpeg in general, that becomes very obvious very quickly. But yeah, we have these stream informations now. What do we do with them? How do we get the audio and the video stream out of a video file? So first of all, let's go to our header and let's add some extra items. So AV stream, so AV stream video, and this also needs to be a pointer. And let's add another one. Also remember the pointer, AV stream audio. So this is where we will store the video stream and the audio stream. So for int I, which is 0, we check if int is the int is smaller than AV format context, the number of streams. So we have number of chapters, number of programs, number of streams. We need streams. And then we add to I. So first of all streams are made with a codec. And so we have video files which are made with codecs like H.264 and such. But we also have audio codecs, which are, for example, AAC. Yeah, it's AAC, okay. Codec parameters. Let's create a quick one, AV codec params. So this is AV, we need to get this from AV format context. We get the streams, and we will check the streams from the integer, from the number of streams. And we need the codec, the codec par. So this will give us the necessary information to check what type of codec it is, if it's an audio or video one. So first of all, if we cannot find AV codec params, AV find codec, we need to decode it. So AV codec find decoder. We go in here. Oops. So from AV codec params, we need a codec ID. What a codec ID is basically an enum. If you cannot find that, basically we continue because we're probably accessing a wrong stream or something that we cannot work with. That does not mean necessarily that the video file is broken or that we cannot find the actual like video stream or audio stream that works for us. It just means that we ran into a stream that we cannot find a decoder for, which can be a problem, cannot be a problem. Else if AV codec params the codec type. So if the codec type is AV media type audio, then we need to add AV stream audio, and we add that to I think just this one. Okay, and then we basically do the same for video. So AV type video, and we change the video stream. And this is all we need to find the correct stream. So now we have our data if everything goes correct. So let's quickly test this. Print working. Let's build again. Okay, let's run. And working. That was very quick. So that's one part solved. But right now we have an option. If we want our video player to only play videos, then we need to make certain that we actually have a video. So if AV stream video is, if this one is empty, we basically print an error and return. If you want to make certain that there's audio included as well, we can also add an audio thing. I won't leave it here, so we can use the video player for both video and audio. And now we need to set up the decoders, because how can we play the video and the audio when we have no decoder? Because a video file, it's actually a very complex thing. If you were to take every frame out of a video and store them in a separate file, like as images, you will have a file that is immensely bigger than the actual video file itself, because there's a lot of compression going on in video files. So we really need a decoder. So first up, I'll set up all the video decoders, and after that the audio decoders. And for this we will actually need another variable here. So AV codec context. So we have AV format context, which is for the file itself. AV codec context is for the specific codecs that we need for the different streams. AV codec context video, and let's just copy this for the audio as well whilst we're at it. And this should work. So first we need to set up an AV codec. Let's just call this AV codec video. And we need to do kind of the same thing as over here. We need to find a decoder. So AV find decoder. So we take our AV stream from the video. We need to get codec par, and then we need to get the codec ID. Because find decoder, it requires an basically an enum ID, which links towards the correct decoder. Normally this should work, but I think I'm doing something wrong. Yeah, no, this needs to be a const, because this is not allowed to change. And now a quick check if this is actually working or not. AV codec context, no, AV codec video. If this one is empty, you basically need to print another thing. Again, these kind of errors only happen when something's really wrong. Well, this can also just happen if you run very out of date hardware. But yeah, you have to go very far back to not have any support. So yeah, we could have a return like -1, -2, so Godot knows which error occurred. For the video editor that I'm making, that's probably something I will do. Return codes like -1, -2. And just have them specified somewhere so I can tell from the editor what went wrong when importing a video file, which may be helpful for troubleshooting stuff. But for the video player, not needed. And then again, we need to allocate codec context. but basically for the decoder, AV codec video, we need to allocate this AV codec allocate context 3. So allocate an AV codec context and set its field to default values. The resulting struct should be freed with AV codec free context. This is important. So what we do in here again, if AV codec context video, then we need to do AV free codec context, and we basically pass the same argument. I think this also needs the whole pointer thing. Let's copy this and make it for the audio as well. So this is already prepared. So yeah, every time when you allocate something, you need to free it afterwards. This is a whole thing from C, because C does not have classes. It cannot automatically unallocate something. Memory management, it's kind of important. But for this we need a codec, and like we have it, we already created that one. And now we need to check if it actually worked, if we were actually able to allocate this data and the codec context. I don't think this works. I think this should be if this returns a null. We should also just have this already. So is open true. So we know the video file is actually open at the end. So what have we actually done in this part? So we created an AV codec from finding a decoder for this codec ID. Then we allocated the whole struct data and such to memory, so we can actually like do things with it. But we still have no idea of the actual video files. We still need to copy all the codec, like the stream parameters, to the codec. Well, we still need to copy the parameters from the video codec to this one, because right now there's basically a fully default one. Like I think it also says on here. So allocate and set the field to default values. Yeah. So let's get rid of those default values. So to copy the parameters, so AV codec parameters copy. So in here we need to pass the codec context for the video, and we also need the codec parameters. So for this we basically need take the stream data, AV stream video, and from here we need to get the codec parameters. So you can copy the parameters from this inside of this one, and I think this should be the pointer thing again. Nope, no, codec parameters to contexts. So you basically copy the parameters from this parameters to the codec context to context. And now we need to open the codecs. So this is a lot of stuff already. So if we just minimize the if statements for the errors, for the error handling. So first we allocate the format context. So we have the context from the file. Then we open the input, open the file. We find stream information. We try to find the streams themselves for the audio and the video. Then we set up the decoder contexts. Then we allocate the the memory for it. Then we then we delete everything. Then we copy the parameters, and then we open the codecs. And this is almost everything. This is almost everything that we need for opening the file. So if AV codec open, I think open 2, yes. So we need some parameters for this as well, some arguments. So we need a codec context. Like we have it, we also have that. Codec context for the video. And we also need a AV codec. And like we have it, we previously created it as well. Codec video. And then there's another one, options. We still don't have any options, so null. And normally this will be fine, yep. If this did not work, we print an error. Cons open video codec. And now we got our video import, like open. We can access all the video data. Let's quickly build this to see if nothing went wrong. Normally it should print working again. Normally it printed working, but Godot is not 100% certain if it's working or not. Okay, no, now it crashed. Now it crashed. So let's quickly see why. It printed working and then it crashed. So program crashed with signal 11. Again, this is what you have to deal with. Okay, so something went wrong, and of what I can see, it's something with AV codec free context. Okay, let's first add the close function as well. So close video, we don't need an argument. Close video. And for now, maybe let's just, I'll try to figure this out later. Is this the problem? Okay, if you run this, now it's working again. Okay, so there's something wrong with this amount and this piece of code. And that's basically how you have to troubleshoot FFmpeg. Just comment things out and see if it works or not. Okay, that works. I think we don't need this. So let's quickly do again. Also works, so yeah, it's probably because we don't actually use AV codec, the whole audio stuff. We have not implemented audio, and that's why it's causing issues. Okay, yeah, no, it's because of the audio. So let's quickly implement the audio. So I was not doing anything wrong. It's just we have not implemented one part yet. So let's take this, copy, and let's change things to audio because it's basically the same thing. Everything where you see video, so boom, 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 audio. Over here as well, audio. Oh, whoops, close video. Yeah, oh, shouldn't change that one. Over here again, the audio. Over here as well, audio. Okay, and this should normally work perfectly. And it's working, so the problem was because of the audio thing. I should not have added this line of code without there actually being some audio. That's it. We can open a video file. I know it's not what people probably think about opening a video file, but this is how you open a video file with FFmpeg. Right now, the data is ready for us to access and seek through and do whatever we want with it. But that will be for the other video. In the next video, I'll show you how to get the audio out of a video file, because that's probably one of the easier ways to show how everything works. A quick recap of what we did today. So we added a close video function, an open video function. We added some basic things so we can access it from different functions. So we allocated the format context, so we open the file, find stream information, get the stream data, allocate and open the codecs for decoding, and we did that for both audio and video. And this took me in total almost 1.5 hours. Oh well, I hope people are still following at this point, because it's only getting worse from here. It's only getting more complicated. But for people who want to know how to implement FFmpeg in their application, this is probably one of the better series and one of the only series I think at this point. Yeah. Okay, and let's get rid of that. Okay, so that's basically it. This video was kind of a long one. I hope people are still following. It's complicated. I cannot really make it look very easy, and even I've been working with FFmpeg now for the last 6 months, and I still make mistakes. There are still a lot of things that I get wrong, but I got everything working. So yeah, I'm just sharing all the knowledge that I have right now and how to make a video player. I'm also working on a video editor, so if you want to see the progress on that, please click subscribe. If you like this video, please click like. This is the third part of this whole tutorial series. Normally tutorial series go like this. Every part gets less and less views, so every like helps to keep the series alive. And a big thank you to all my Ko-fi supporters for making these type of videos possible, because these take a lot more time than I expected to make. Thank you all for my Ko-fi supporters for supporting me, and I'll see you all in the next one, in the next video, in the next part, where we will be getting the audio out of a video file. Thanks for watching, and I'll see you in the next one. Bye bye.